Aura Components Basics. Connect to Salesforce with server-side controllers. Learning objectives. After completing this unit, you'll be able to create Apex methods that can be called remotely from Aura component code, make calls from Aura components to remote methods, handle server responses asynchronously using callback functions, stretch goal. Explain the difference between C dot, C colon, and C dot dot. Server-side controller concepts. So far, everything we've done has been strictly client-side. We're not saving our expenses back to Salesforce yet. Create a few expenses and then hit reload, and what happens? That's right, all the expenses disappear. Woohoo! Free money. Except accounting just called and, well, they're kind of humorless about that kind of thing and actually don't want to be reimbursed for those expenses, which are otherwise coming out of our pocket. Yikes. Saving our data to Salesforce is a PO bug for sure. Kidding aside, it's finally time to add server-side controllers to our app. We've been holding this back while we get the basics down. Now that you're ready for it, let's dive into some pictures, that is. Let's make sure we know where we're headed and that our gas tank is full before we hit the road. First, let's revisit the diagram we saw in this module, a very high-level look at the architecture of Lightning Components apps. Up to now, everything we've looked at has been on the client side of this picture. And note, we simplified by merging controllers and helpers here. Although we've referenced a custom object type, expenses $_C, which is defined on the server side, we've never actually touched the server directly. Remember how we talked about wiring together different elements to create a complete circuit? The expenses form that we built in the last unit might look something like this. The circuit starts with the create button, which is wired to the click create action handler, number 1. When the action handler runs, it gets values out of the form fields, number 2, and then adds a new expense to the expenses array, number 3. When the array is updated via set, it triggers the automatic rendering of the list of expenses, number 4, completing the circuit. Simple, right? Well, when we wire in server-side access, the diagram gets a bit more complicated. More arrows, more colors, more numbers. We'll hold off on explaining all of it for a moment. What's more, this circuit doesn't have the same smooth, synchronous flow of control. Server calls are expensive and can take a bit of time, milliseconds when these things are good, and long seconds when the network is congested. You don't want apps to be locked up while waiting for server responses. The solution to staying responsive while waiting is that the server responses are handled asynchronously. What this means is when you click the Create Expense button, your client-side controller fires off a server request and then keeps processing. It not only doesn't wait for the server, it forgets it ever made the request. Then, when the server response comes back from the server, code that was packaged up with the request, called a callback function, runs and handles the response, including updating client-side data and the user interface. If you're an experienced JavaScript programmer, asynchronous execution and callback functions are probably your bread and butter. If you haven't worked with them before, this is going to be new and maybe pretty different. It's also really cool. Querying for data from Salesforce. We're going to start with reading data from Salesforce, the load list of existing expenses when the expenses app starts up. Note, if you haven't already created a few real expense records in Salesforce, now would be a good time. Otherwise, after implementing what follows, you might spend time debugging why nothing is loading when there's actually just nothing to load. Your humble author falls for this one all the time. The first step is to create your Apex controller. Apex controllers contain remote methods your Lightning components can call. In this case, to query for and receive expenses data from Salesforce. Let's take a look at a simplified version of the code. In the developer console, create a new Apex class called Expenses Controller and paste in the following code. We'll go into Apex controllers in some depth in the next section, but for now this is really a straightforward Apex method. It runs a SQL query and returns the results. There are only 2 specific things that make this method available to your Lightning Components code. The @Aura enabled annotation before the method declaration. Aura is the name of the open source framework at the core of Lightning Components. You've seen it used in the namespace for some of the core tags such as Aura::component. Now you know where it comes from. The static keyword. All @Aura enabled controller methods must be static methods and either public or global scope. If these requirements remind you of remote methods for Visualforce's JavaScript remoting feature, that's not a coincidence. The requirements are the same because the architecture is very similar at key points. One other thing worth noting is that the method doesn't do anything special to package the data for Lightning Components. It just returns the SQL query results directly. The Lightning Components framework handles all the marshalling or unmarshalling work involved in most situations. Nice. Loading data from Salesforce. The next step is to wire up the expenses component to the server-side Apex controller. This is so easy it might make you a bit giddy. Change the opening aura::component tag of the expenses component to point at the Apex controller like this. The new part is highlighted in bold, and yes, it really is that simple. However, pointing to the Apex controller doesn't actually load any data or call the remote method. Like the auto wiring between the component and client-side controller, this pointing simply lets the two pieces know about each other. This knowing even takes the same form, another value provider, which we'll see in a moment. But the auto wiring only goes so far. It remains our job to complete the circuit. In this case, completing the circuit means the following. Number 1, when the expenses component is loaded. Number 2, query Salesforce for existing expense records. And number 3, add those records to the expenses component attribute. We'll take each of those in turn. The first item, triggering behavior when expenses component is first loaded, requires us to write an init handler. That's just a shorthand term for an action handler that's wired to a component's init event, which happens when the component is first created. The wiring you need for this is a single line of markup. Add the following to the expenses component right below the component's attribute definitions. The aura::handler tag is how you say that a component can, well, handle a specific event. In this case, we're saying that we'll handle the init event and that we'll handle it with the doInit action handler in our controller. Setting value equals open curly bracket bang this close curly bracket marks this as a value event. What this means is too complex to go into here. Just know that you should always add this attribute value pair to an init event. Calling server-side controller methods. 1 step down, 2 to go. Both of the remaining steps take place in the doInit action handler, so let's look at it. Add the following code to the expense components controller. Before you feel lost with all the new things here, please notice that this is just another action handler. It's formatted the same and the function signature is the same. We're in familiar territory. That said, every line of code after the function signature is new. We'll look at all of them in a moment, but here's the outline of what this code does. First, it creates a remote method call. Second, set up what should happen when the remote method call returns. And third, queue up the remote method call. That sounds pretty simple, right? Maybe the structure or specifics of the code is new, but the basic requirements of what needs to happen are once again familiar. Does it sound like we're being really encouraging? Like maybe we're trying to coach you through a rough patch? Well, we need to talk about something tough. The issue appears in the first line of code in the function. This line of code creates our remote method call, or remote action. And at first, the component.get part looks familiar. We've done that many times at this point. Except, well, before it was v.something that we were getting, with v being the value provider for the view. Here it's C, and yes, C is another value provider, and we've seen a C value provider before in expressions like press equals open curly bracket bang C dot click create close curly brackets, and action equals open curly bracket bang C dot do init close curly bracket. Those expressions were in component markup in the view. Here, in the controller, the C value provider represents something different. It represents the remote Apex controller. Wait a minute. Are you telling me we have C, the client-side controller, C, the default namespace, and C, the server-side controller, all in Aura components? Well, in a word, yes. Deep breaths. Look, we'll be honest with you. If we had it all to do over again, we might have made some different choices. While the choices we made weren't accidents, 3 C's is definitely an opportunity for confusion. We get confused too. But, as they say, it is what it is. Forewarned is forearmed. Now you know. Identifier, C dot. Context, component markup, meaning client-side controller. Identifier, C dot. Context, controller code, meaning server-side controller. Identifier, C colon. Context, markup, meaning default namespace. Okay, back to our code. Before we get sidetracked, we're going to look at this line, where in earlier code, component.get v.something returned to us a reference to a child component in the view component markup, component.get c.whatever returns a reference to an action available in the controller. In this case, it returns a remote method call to our Apex controller. This is how you create a call to an @Aura-enabled method. The next line, action.setCallback, is a block of code that will return when the remote method call returns. Since this happens later, let's set it aside for the moment. The next line that actually runs is this one. We saw $A briefly before, but didn't discuss it. It's a framework global variable that provides a number of important functions and services. $a.enqueue action adds the server call that we've just configured to the Aura component framework request queue. It, along with other pending server requests, will be sent to the server in the next request cycle. That sounds kind of vague. The full details are interesting and important for advanced use of Aura components. But for now, here's what you need to know about $a.enqueue action. It queues up the server request. As far as your controller action is concerned, that's the end of it. You're not guaranteed when or if you'll hear back. This is where that block of code we set aside comes in. But before we talk about that, a little pop culture. Server calls, asynchronous execution, and callback functions. Carly Rae Jepsen's single Call Me Maybe was released in 2011 to critical and commercial success, hitting #1 in more than a dozen countries. To date, it has sold more than 18 million copies worldwide and is apparently one of the best-selling digital singles of all time. The most memorable line from the chorus is, "Here's my number, so call me maybe." In addition to being upbeat and dangerously catchy, it's a metaphor for how Aura components handle server calls. Here's how. Let's look at our action handler and pseudocode. Maybe we should explain the parameters to action.setCallback in more detail. In the real action handler code, we call it like so. This is the scope in which the callback will execute. Here, this is the action handler function itself. Think of it as an address or maybe a number. The function is what gets called when the server response is returned. So, here's my number. Call me maybe. The overall effect is to create the request, package up the code for what to do when the request is done, and send it off to execute. At that point, the action handler itself stops running. Here's another way to wrap your head around it. You might bundle your child up for school and hand them a list of chores you want them to do when they come home after classes. You drop them off at school and they go to work. While you're at work, you're doing your work, secure in the knowledge that your child, being a good kid, will do the work you assign to them when they get back from school. You don't do that work yourself, and you don't know when exactly it will happen, but it does. Here's the last way to look at it. Again, in pseudocode, this version unwraps the callback function to show a more linear version of the action handler. We'll say it again. Asynchronous execution and callback functions are de rigueur for JavaScript programmers, but if you're coming from another background, it might be less familiar. Hopefully, we've got it down at this point because it's fundamental to developing apps with Lightning components. Handling server response. Now that we've got the structure of creating a server request down, let's look at the details of how our callback function actually handles the response. Here's just the callback function. Callback functions take a single parameter, response, which is an opaque object that provides the return data, if any, and various details about the status of the request. In this specific callback function, we do the following. Number 1, get the state of the response. Number 2, if the state is success, that is, our request completed as planned, then Number 3, set the component's expenses attribute to the value of the response data. You probably have a few questions, such as, what happens if the response state isn't success? What happens if the response never comes back? Call me maybe? How can we just assign the response data to our component attribute? The answer to the first two are that, unfortunately, we're not going to cover those possibilities in this module. There's certainly things you need to know about and consider in real-world apps, but we just don't have the space. The last question is the most relevant here, but it's also the easiest to answer. We've defined a data type for the expense attribute, and our server-side controller action has a method signature that defines its return data type. The types match, and so we can just assign one to the other. Aura components handle all the details. You can certainly do your own processing of the results and turn it into other data within your app, but if you design your server-side actions right, you don't necessarily have to. Okay, that was a lot of different ways to look at a dozen lines of code. Here's the question. Have you tried your version of our app with it yet? Because we're done with the loading expenses from Salesforce part. Go reload the app and see if the expenses you entered in Salesforce show up. Apex controllers for Aura components. Before we take the next step in developing the app, let's dive a little deeper into that Apex controller. Here's a look at the next version, which we'll need to handle creating new records as well as updating the reimbursed checkbox on existing records. The earlier version promised a stern lecture, and that's coming. But first, let's focus on the details of this minimal version. First, we've added only one new at-or enabled method, save expense. It takes an expense double_c object, and upserts it. This allows us to use it to both create new records and to update existing records. Next, notice that we created the class with the with sharing keywords. This automatically applies your org's sharing rules to records that are available via these methods. For example, users would normally only see their own expense records. Salesforce handles all the complicated SOC rules for you automatically behind the scenes. Using the with sharing keyword is one of the essential security measures you need to take when writing server-side controller code. However, it's a measure that's necessary but not sufficient. Do you see the comments about performing is accessible and is updated checks? With sharing only takes you so far. In particular, you need to implement object in field level security, which you'll frequently see abbreviated as FLS, yourself. For example, here's a version of our get expenses method with this security minimally implemented. It's quite an expansion from our initial one-liner, and it's still just adequate. Also, describe calls are expensive. If your app is calling this method frequently, you should find a way to optimize or cache your access checks per user. Like with SLDS, we simply don't have the space to teach all of the details of secure Apex coding. Unlike with SLDS, taking responsibility for the security of the code you write is not optional. If you haven't read the Securing Code Practices article and the resources, please add them to your queue. Okay? Close Stern Lecture tag. Saving data to Salesforce. Before we implement the add expense form for real, no cheating, let's first look at how creating a new record is a different challenge from reading existing records. With DoInit, we simply read some data and then updated the user interface of the app. Straightforward, even if we didn't have to get Carly Ray involved in the explanation. Creating a new record is more involved. We're going to read values from the form, create a new expense record locally, send that off to be saved on the server, and then when the server tells us it's saved, update the user interface using the record returned from the server. Does that make it sound like it's really going to be complicated? Like maybe we're going to need the Rolling Stones and a whole album of songs to help us out with the next explanation? Let's take a look at some code, and you can decide for yourself. First, make sure you've saved the updated version of the Apex controller, the preceding version that includes the save expense method. Remember when we showed you how to handle the submission form? When at least one of the fields is invalid, you'll see an error message and the form isn't submitted. The error message clears when all fields are valid. Because we put all of the details of and all the cheating on creating a new expense into the helper create expenses function, we don't need to make any other changes in the controller. So far, so easy. So all we need to do is change the create expense function in the helper to do all of those complicated things we mentioned previously. Here's that code. Is that as complicated as you were expecting? As many lines? We hope not. In truth, there is only one new thing in this action controller, and it's easy to understand. Let's walk through the code. We began by creating the action component.getC.saveExpense, getting the new Apex controller method. Very familiar. Next, we attach a data payload to the action. This is new. We need to send the data for the new expense up to the server. But look how easy it is. You just use action.setParams and provide a JSON-style object with parameter, name, parameter, value pairs. The one trick, and it's important, is that your parameter name must match the parameter name used in your Apex method declaration. Next, we set the callback for the request. Again, this is what will happen when the server returns a response. If you compare this callback function with our original create expense helper function, it's virtually identical, minus the disgusting hack. Just as in the prior version, we get the expenses attribute, push a value onto it, and then set it. The only real difference is instead of pushing our local version of the new expense into the array, we're pushing the server's response. Why does this work? Because the server-side method upserts the, in this case, new record, which stamps an ID onto it and then returns the resulting record. Once the server-side and client-side data types match, so we don't have to do any extra work. And, well, that's it. No Rolling Stones needed. Things to watch out for. While we've covered all of the essentials for connecting your client-side Aura component code with server-side Apex code, there are a couple of things that are kind of worth pointing out before they bite you in the you-know-where. The first issue is case sensitivity, and this boils down to Apex, and Salesforce in general are case insensitive, but JavaScript is case sensitive. That is, name and name are the same in Apex, but different in JavaScript. This can and will lead to absolutely maddening bugs that are completely invisible to your eyes, even when they are right in front of your face, especially if you've been working with non-Lightning Components code on Salesforce for a while. You might no longer think about the case of object and field names, methods, and so on at all. So here's a best practice for you. Always use the exact API name for every object, field, type, class, method, entity, element, elephant, or what have you. Always, everywhere, even when it doesn't matter. That way, you won't have problems, or at least not this problem. The other issue we like to draw your attention to is the nature of required. We can't resist repeating a famous quotation. You keep using that word. I do not think it means what you think it means. In the code we've written so far, we've seen at least two different kinds of required. In the markup for the add expense form, you'll see the word used two ways. For example, on the expense name field. The Lightning :input tag has its required attribute set to true. These both illustrate only one meaning of required, which is set the user interface of this element to indicate the field is required. In other words, this is cosmetic only. There's no protection for the quality of your data here. Another meaning of the word required is illustrated in the validation logic we wrote for the same field. The word required is nowhere to be seen, but that's what the validation logic enforces. You must set a value for the expense name field. And as far as it goes, this is great. Your expense form won't submit a new expense with an empty name, unless you know there's a bug. Or maybe some other widget uses your same server-side controller, but doesn't do its form validation so carefully, and so on. So this is some protection for your data quality, but it's not perfect. How do you reinforce, and we mean enforce, a data integrity rule about, in this example, expense name? You do it server-side, and not just anywhere server-side. You put the rule in the field definition, or you encode it into a trigger. Or, if you're a belt and suspenders kind of engineer, as all right-thinking engineers are, both. For true data integrity, when required means required,